Assalamualaikum and very good morning to all. Um, Thank you for joining us this morning. I'm Rafidi from Oil, Gas and Mining Technical Division. I'll be the moderator for today's talk. I'm happy to share that today the talk is jointly organized. We have our Chemical Engineering Technical Division together with us, Oil, Gas and Mining Technical Division. So it's a very interesting topic. We have a special speaker basically joining us actually from Seoul, South Korea. So annyeonghaseyo to Cik Muhamad Saifuddin Sidek. He's not Korean, by the way. So he's Malaysian, but it's just that because of his work, he's currently stationed in Seoul. I'm happy. I'm very thankful for him to take some time today on a Saturday morning to join us to share his knowledge, to share his expertise with regards to the topic today. So participants online. And before we start, let me just give a short introduction of our speaker. I'm not sure whether you can ask him later because he's in Korea. I'm not sure whether he's a K-pop fan or not. we can ask him afterwards. So let me just give a short introduction of our distinguished speaker for this morning. His name is Muhamad Saifuddin Sidek. So he's actually started his career as a process engineer in 2008, and he has 15 years of engineering and operational experience, particularly in gas treatment, liquefaction of LNG processing plant and gas processing plant. He develops capability in implementation of plant monitoring tools, plant optimization study, troubleshooting, plant shutdown, and carry out process simulation model. In addition, he has also undertaken many engineering design assignments, ranging from feasibility studies, de-bottlenecking studies, plant modification, basic design, coupled with some project management work. And Cik Muhamad Saifuddin is a chartered engineer from the Institution of Chemical Engineers, iChemE, and he's also a panel member for the development of PETRONAS skill group technology inventories and rulers. And he's also a technical trainer for skill group 16 discipline in PETRONAS. So Cik Saifuddin, he graduated with a BSc, Bachelor of Science in Chemical Engineering degree from University Technology Malaysia, UTM, in 2008. So our topic this morning will be on the how chemical cleaning restores the integrity of oil and gas plant equipment. So without further ado, let us all give a virtual applause to our speaker, Cik Muhamad Saifuddin. Cik Saifuddin, I pass the platform to you.
All right. Thank you, J. Rafidi. First of all, thank you very much to all of you that willing to spend some time, even though during the weekend, to have the sharing session and as well as the exchange the knowledge with us. Then I think just a little bit about myself. My name Muhamad Saifuddin. I basically I'm working with PETRONAS. I think it's about 15 years now. I think I started as a graffiti mentioned earlier. I started my career in PETRONAS, and I think last time I was in Bintulu. I joined the group technical solution under PETRONAS corporate, and then yeah, recently been assigned to one of the new innovative technology that we are doing right now is on the at the overseas assignment. All right. I think that without further ado, I would like to basically to share with all of you on the one of very interesting topic and very exciting experience for myself doing the alternative way and more on the fit for purpose way, how we can destroy back our integrity of the plant without doing the conventional way. So for today, I think I would like to share my experience doing the chemical cleaning method to restore or reinstate back the integrity of the plant equipment itself. All right, I think by end of this presentation, I think we are going to have the lengthy technical question and some of other question from the audience. I think during that time, maybe I open for everybody to share or to ask any question related to this presentation and to this sharing. All right, we start. Okay, in terms of the content, I'm going to go with very high level explanation in terms of the summary first, and then a little bit about the background, and then we will go with the scope of work and some objective, and next is about how we execute this method, and last but not least about the findings lah. And then the number 6 is on more on the, 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 the recommendation and the execution result. All right, let's we go with the executive summary first. Right. First, in terms of the what we call it, the overall findings and overall summary, what I would like to share to here is about the storyline. Okay, the first part. Let me. I think maybe I can use there's a pointer here, right? The first part is about our what we call it, our business need. What we need to understand that during that time, our what we call it, our plant having some issue in terms of the leakage and in terms of the corrosion, which is ultimately limited our production during that particular time. So that's the objective. Is basically we have to find a way how can we restore back our capacity during that time. But I just want to share with you, this one is more on the cryogenic system, which is we call it the sub temperature system, which is normally we are operating lower than 0. So this kind of the condition, and then after that, we as a team, we have to come out the best solution. The best solution is not only in terms of the engineering, it's not only in terms of the budget, it's not only in terms of the schedule, or it's not only in terms of the safety, but it's totality. It's about how can you go with the fit for purpose solution. So that's the second part, which is how we should consider the best solution to fix and to meet the business need, and as well as governed by safety, and as well as governed by the integrity of the economy itself. Okay, after the in term of strategy, if you look at here, what we try to achieve during that time, we try to find the alternative technology, or rather than using the conventional method. And then we also start to establish the right strategy. If you look at here, we build our own 3D model for our plant in order for us to have the better accessibility, better evaluation, and do the right decision during that time. We will go through detail on every single topic later. And then during that time also, we don't have any reference yet in terms of what kind of chemical or what kind of the solution that we have to consider for chemical solution. So during that time, we try to establish as a team, we collaborate with the partners and other division of within our company. So we try to find the right solution and to the right service. To the right service, that means to the right to the cryogenic service. So this is the main strategy that we established earlier. So if you look at right hand side, the top one is the findings that we found during the execution. The top two picture is, if you look at here, is very badly corroded in our piping, and then the bottom part is more on the after our execution. If you look at here, the improvement is significant observed, so which is something that we are sharing the success and sharing the best method that we would like to share with all of you today. Okay, this one is more on the high level of the journey. Okay, the second part is, if we look at here, is the challenges what we facing back then, last time. First, because this one is more, this system, the cryogenic system is normally and conventionally no one doing the chemical cleaning for cryogenic. That's a first number one, the mindset, the complexibility. And then, as I told you earlier, we don't have the reference chemical, that what kind of chemical we have to use. And last not least is about the, of course, we must have the what we call it, the very tight schedule that allocated, and then we have to find the best solution, which is, as I told you, is fit for purpose lah. And then from scratch, we also develop our own simulation, because every single method that we use or chemical we use, we have to ensure that thermodynamically found or thermodynamically right. We cannot allow to have finding by thermodynamic showing us the method is not right. So by theoretically, we have to ensure the method is right. That's what we establish, and that's a kind of the challenges lah. Last but not least, I can share you here the result. I think after 1.5 years, this journey, after 1.5 years, this journey, we executed in the real condition, real plant, with the real situation, real congested area. So we are managed to Alhamdulillah, we are managed to make it, and we are managed to restore back our capacity of the plant itself by having and cleaning the corroded piping and the limitation of the piping itself, which is tied back to our original objective today, which is restoration of the integrity of equipment itself. All right, then that's the overall the high level of the summary of the method that I would like to share today. Okay, now we start with a little bit about the background. Okay, all right. Hold on. Okay, what I can share to you, I think after several number of time we operate the plant itself, we found that after 2018, we found that the production of our steel gas and as well as our main product start to degrade. So if you what I can conclude here, there is something that limiting our production. If you look at here, after the 2018, the production start to cap or limited at 70%. So something that is having or something is limiting our plant. So during that time, we start to establish the root cause, and then after that, we found that the contribution is safe because of the chloride corrosion. Okay. Okay, this is the example that we found in our plant. So badly corroded. Of course, piping itself and our internal column itself. So if you look at here, the what we found, the corrosion itself is heavily contain the chloride. We took some sample and we do some analyze. So if you, it's basically what we found is mostly is chloride. So what we conclude from here is moving forward, we have to find a way to remove entirely chloride, and after that we have to ensure there is no more chloride that can attack our plant anymore. Okay, what I can summarize here from our root cause, the chloride corrosion is only will happen if the condition is above 0 degree with a very high concentration of the chloride and as well as the free water. So that's mean this presence of chloride, even though we have the chloride, but if we don't have the free water, then it won't happen. So what we can conclude during that time, what basically attack our system is basically the hydrochloric acid itself, HCl. If that's our main root cause lah. And then in fact we also do some reference check. If we look at here, we do some reference check to API recommended practice 571. If you So they mention here for carbon steel, especially because of some of our piping itself in carbon steel. So in carbon steel, they will start to have the impact of the chloride corrosion if you have the pH at concentration high below 4.1. That's what we found during our root cause analysis. Okay, that one is more on the what basically we found and what we established the root cause that attacking our equipment integrity, the one that we established back then before we decided to proceed with the chemical cleaning method. Okay, all right, then we go with the objective and scope of work. Objective, I think objective, as I mentioned earlier, we have to restore back our production. That's the main objective. But what I want to share here is the scope of work. Okay, I think this is the one that I think I would like to share and to everybody, because I think from this slide, what I want to express here is we are having very good teamwork among internal PETRONAS division as well as our external partner. Okay, what I want to find here, because this kind of this problem or this kind of the issue is never been in PETRONAS since day one. So this is the first time that we are having this kind of issue in the cryogenic system. So all in all, what we established during that time, we established every single group that have to look after each scope. Okay, so basically we established 4 scope. Why we have the 4 scope? Because from the strategy itself, we have to have the dedicated team to look after in terms of engineering, look after in terms of the execution, look after in terms of chemical selection. So those scope and those method, we have to establish every single team. Then at the end of the day, all of them are reported to one leader, which is we call it the KRA itself. The leader of the KRA is basically led by myself lah. So we go with the group number 1. WP is stand for what we call it, work process number 1. So for first group, they have to find the best chemical solution, and then that's number 1. And then they also have to find method how can we evaluate that chemical, and last not least, they have to propose how can we execute that chemical cleaning itself. So that's the group number 1 scope. For group number 2, of course, using the chemical, we have to anticipate the corrosion impact. we have to anticipate the micro structure impact. So how can we evaluate that? How can we establish the criteria, how high that we allow in terms of the corrosion or in terms of the loss of the thickness? So because any of the day, even though we are doing the chemical cleaning, we have to ensure the thickness loss or corrosion allowance still within our allowable limit. So that's a group number 2 job. They have to establish the corrosion evaluation, and they have to establish the corrosion monitoring after the cleaning itself. That's group number 2. Group number 3 is, I think group number 3 is more on the engineering work. They have to establish the how engineering looks like and how the site execution looks like during the execution of the chemical cleaning itself. What they have to do is they have to come out the best strategy during that particular execution time, how we can execute within the time frame. And then last not least, in terms of the engineering itself lah, and in terms of the collaboration with the other activity nearby with the chemical cleaning area itself. Okay, last not least is about the project execution and the project management lah. Because project management and project execution is they the one who execute the job, they the one to execute the actual progress, and they the one who manage and coordinate with our partner. So all in all, is basically in terms of the scope of work, we cover everything from from scratch to completion. So if we look at here, from lab study, from the research itself, until the execution, until the product end. So we make it every single thing within the entire group, cover everything. So that's mean we cannot miss anything. We go with, that's the scope of work lah, the one that I would like to share with your team. Okay, we go with the method after we establish the scope of work and how we execute. Okay, in the simpler way, we can divide the methodology by 4 main steps. The first one, as I told you before, is we have to understand the scope, and then we have to understand the approach that we have to, the one that we choose. First, before you solve the problem, you must understand the problem. You cannot, I think, as what you call it, the normal mechanism or normal approach, we cannot totally solve the problem if you don't understand the problem, or you don't understand what is the contributor for that problem. That's the most important thing. Okay, and then how we can by technically or by theoretically, how can we ensure or having the high confidence that our proposal or our method is right. So how we do that is basically we are doing the simulation. We do some simulation. So from that simulation, theoretically, we show to our management, okay, this is the best method based on the simulation. Then by then we can start to imagine how it's behave in the practical way. Last not least, we have to understand the scope. The scope that's mean we we cannot entirely solve the problem with one solution. So we must have to ensure that the corroded or the impacted equipment or piping is not all of them. It's about the right one and only the one that impacted. So we have to ensure and we have to identify where exactly the pain point. We cannot just simply all rounded. So how we establish during that time, we do the sum selection and then we establish about the scope, is we call it 14 loops. Okay, and then after we understand and after we finalize the approach, we start to optimize and we start to play around with the schedule and budget given to us. And then from that, we utilize the chemical that we selected, and then we start to establish our own procedure, and we establish our own criteria. I think we can go through a detail about the criteria later in the following slide, because of as I said, because of this method is more on the fit per purpose, which is try to suit our safety requirement and try to suit our technical requirement. And last not least, of course, we execute the plan itself by having the right coordination and healthy coordination with all the partners, alignment with the schedule with the other activity nearby. And last not least, after all the completion, we record the lesson learned, and because after that we make this practice to become the reference to other PETRONAS operating plan and other future PETRONAS project. So this is something that everybody who involved in this project is having the good time and having the good sharing with the other our colleague with the other PETRONAS lah. Because this one is the first time that in our history, so we make this one as a reference. Okay, that one is more on the methodology. I think we can have the further discussion or further detail if anyone who would like to know detail. I think we can have the further detail on the technical, on the methodology itself. Okay, we go with the result finding. I think this one is more on the milestone and the key activities, the one that we executed last time. If you look at here, I think it's about we are spent about 1.5 years lah, from their study until the execution itself. I think we started in 2020. I think during that time is MCO time, so it's quite another challenges for us. We started with their study, and then we managed to finish the chemical selection, I think in middle of 2000, sorry, I think the Q1 of 2021. And then last not least, the first execution and the bigger scope execution itself, we completed in August 2021. I think all in all, after completion, it's about 1.5 years. All right, now let's we go a little bit about the high level, the method itself and the scope itself lah. Okay, first, how do we, as I told you before, we have 14 loops or 14 scope that we have to carry out. How we establish that scope itself? First, during the normal operation, we do observe and we do establish the checking in terms of the high differential pressure across the some equipment. That's number one. So because the normal operating pressure, you didn't allow or you didn't anticipate any high differential pressure. So if the high differential pressure start to hit the alarm, so there's something wrong happen. So that's a number one, criteria number one that we establish. And then during during the previous maintenance or previous shutdown, we also open the certain equipment. That's during that time we start to establish which equipment that having that kind of the corrosion, that having that kind of the reliability defect. And then of course from the inspection we can have the inspection report, because every single thing we can check in terms of thickness, what happened to their thickness. And then on top of this technical part, we also look at in terms of constructability part, which is if we choose to that particular equipment, can we do that chemical cleaning or not? Because we have to look at in terms of accessibility, and then we also have to look at in terms of the practicality. And then the last two is more on the material itself, and as well as the last not least, again we have to verify with the simulation whether if we go with the selected scope, is it getting towards or not. Okay, let's a little bit touch on the material of the construction. Why I say that the material of construction? Because carbon steel or low temperature carbon steel or stainless steel itself, we must use different chemical. We cannot use the same chemical because each material have their own individual compatibility with each chemical. So that's the reason why we have to differentiate in terms of the material of construction itself. All right, and then this one is more on the area that we are focusing here. So if you look at here, the one that in the red box is the one who impacted, or the one that I explained earlier, is more on the cryogenic system. Why we are talking about the cryogenic system? Because of this area is having some corrosion that impacted, and the corrosion from the chloride itself. Other than that area, we didn't observe, or we didn't see any impacted equipment reliability issue. It's only this area. Okay. All right. Now we go to a little bit deeper. This is the overview that I think I would like to share with audience here. This is the area and system that we carry out the chemical cleaning here, chemical cleaning itself. Just try to make it differentiate. The red one is, you look at the red one itself, is the badly impacted by chloride corrosion. This is the red line, and then the yellow line is the just traces of the chloride itself. And then the third line is more on the carbon steel, and the straight line is more on the the dotted line is the stainless steel, and the straight line is on the carbon steel. So why we establish this overview? Because we have to ensure that we do the cleaning itself to the right area. We don't want to spend the entire area having the chemical cleaning, because why we should do the unnecessary scope. We just need to spend, or we just need to do the rectification for needed or fit for purpose only. So that's a message from here lah. Okay, that's number one. And then number two is why we would like to show here. We want to really focus the one who have the very high chloride. If you look at here, the bottom of this column is mostly having the high chloride. There's another one. And then another thing is because of we have to understand the hydrochloric acid behavior. They only can have the what you call it in the liquid form. They can only have the liquid form at the lower temperature. They won't impact you if they are in the vapor condition. They only impact you in the liquid condition. So that's the why we establish this kind of the overview of the scope and overview of the chloride corrosion impact itself. Okay, let's we go to next slide. Okay. All right, then this is the one that high level overview of the strategy. As I told you here before, it's basically after we identify the scope, we segregate it and we group it into 14 loops. So why we call it 14 loops? So that's mean during the execution, we want to ensure that every single loop we can have the complete circulation of the chemical cleaning itself. Okay, First of all, allow me to share on the how we establish the chemical cleaning. Of course, the chemical cleaning itself, we have to make it in the closed loop. So first, the basic thing what we need is the device that can establish the or can make it the circulation circulation of the chemical itself, which is of course chemical is liquid, so you require a pump. The pump, the what I'm referring here is the external pump. So during the execution, we bring the external pump, which is the one that can compatible with stainless steel and compatible with the carbon steel. So we have the dedicated pump. So we have the external pump, and then we also establish with the flexible hose. I think it's about 6-inch flexible hose. Why 16-inch flexible hose? Because of bioengineering wise, we have to ensure that we have the very minimum pressure drop across the flexible hose. So we connect with the flexible hose, and then after that we establish the temporary flanges, and then we connect with the piping of the loop, which is the what we call it the 14 loop itself. And after that, that chemical will return. Of course, all the corrosion, all the dirty, all the debris will be captured by our external filter itself. Last not least, after that, they will revert back and they will return to our temporary tank itself, and then having the adequate or enough head. After that, we can send back to suction of the pump, and then we keep circulating it. So that's the high level of the concept for establish or execution of the chemical cleaning itself lah. Okay, that's what the one that we established. And number one is the 14 loops, and then of course inlet and outlet of the tie-in for temporary loop itself we have to establish. And then what we would like to highlight here, because of this unit, the one that I mentioned earlier, the cryogenic system itself is not the one who designed for chemical cleaning. We never designed this cryogenic system for chemical cleaning, so it's not in our original design intent. So of course we are anticipating and we are facing some complexibility of the to assess that piping itself. Last not least is, I think this one, after the chemical cleaning, we have to find a way how we remove entirely all the chemical and all the traces of the chloride itself completely, which is, I think we will go through later on the method how we remove all the remaining chemical using the nitrogen dry out itself. I think this one I also will share on the method lah. Okay. All right. I think this is the high level how we execute the chemical cleaning itself. Right. As I told you earlier in the first, I think the earlier slide, about the 3D model. If you look at here, the one that before we start, we having, I think, quite high, high volume of the engineering work that we established, because before this we don't have that kind of the 3D model for our scope of work. So we established exactly same as the actual plant located, and then every single dimension we established a 3D. So if you look at here, the one that the blue one is more on the vapor phase, the what we call it, the yellow one is more on the two phase, and last not least, there are some, one of them is more on the liquid, one is more on the liquid phase. So if you look at here, before we execute, we know how does it looks like during the execution, because we have every single 3D model. So we can we can imagine during preparation how during the execution itself will take place. Okay, and then one more thing here, if you look at here, we also have during the preparation, we also start to establish the differences between blue and yellow, because some of the blue is different, what we call it, different pipe class, and some of them different pipe class. All right, that one is more on the 3D model. And then I think in the slide earlier, I also mentioned about the chemical cleaning selection itself, how we establish the criteria itself. I think the one here is more on the chemical engineering part. Okay, I give you the number one, how we establish the chemical selection first. Number one is in terms of the chemical performance itself. Okay, chemical, what kind of chemical, the one that we choose, I think for what kind of chemical or every single chemical equation, I think maybe you can contact me personally lah if you would like to know what kind of chemical that we are using. But what I want to establish and share here, how we end up with the final selection because of the criteria. The first number one in terms of the performance itself. Every single chemical that we test, we have to ensure we are able to meet the acceptance criteria. What is the acceptance criteria? The acceptance criteria itself, after the cleaning itself, we have to ensure the chloride itself must less than 50 ppm. Why less than 50 ppm? Because our standard, we go with the demi water standard. Of course, your demi water normally is less than 50 ppm. So that's our requirement. We established that our requirement. And then in terms of execution, that chemical must able to meet the schedule given. And then last not least, after the chemical cleaning itself, we have to ensure that traces of the chemical itself, the pH is between 6 to 8. Why 6 to 8? Because of we have to ensure it's close to demi water quality itself. That's number one. And number two, in terms of compatibility. Why I said compatibility is more on the try to limit back and reflect with the safety requirement. We have to ensure that chemical that we choose, there is no VOC. What is the VOC? Volatile organic component. So this kind of the VOC we cannot allow. If anything chemical that we choose, if we found there is a VOC, then we will consider that one is not qualified. So that's number one. Number two, we also need to ensure that there is no side reaction. There is no H2S release, there is no carbon monoxide, and there is no depletion of the oxygen itself. Because we cannot allow this kind of situation happen during the execution. So this one is more on the safety and performance. Last not least, the chemical chosen must ensure that they didn't have any compatibility or any side reaction with traces of our product or traces of any hydrocarbon in our system, which is we worried later after we start up again, we will end up with the additional problem or new problem, which is example for forming problem. So this kind of thing that we have to ensure the one that we choose must friendly or must compatible with our system. Otherwise, we will solve one problem and we will end up with a new problem. We don't want to have another problem. That's our intention for number two. Last not least is, as I said earlier, corrosion. We have to ensure chemical chosen corrosion rate is within our range. How we establish our range? Yes, we do have some checking with the NES, reference from international code, and we also do some checking with the required thickness for our remaining life of plant itself. As I said, it's very difficult to find the best chemical to fit for number 1, 2, 3, because at the end of the day, you have to ensure the criteria itself is fit for purpose. So that means the thickness itself, as long as the thickness itself can last for our plant remaining life, it's good for us. That's the what you call it, the intention number 3. All right, this is how we do the chemical cleaning lah. Okay, we do the chemical cleaning for chemical selection for carbon steel. And then we go to next to stainless steel. I think stainless steel is more straightforward because carbon steel we don't have the what we call it, the reference earlier, so that's why it's a little bit challenges. But for stainless steel quite straightforward. We go with the, I think quite common, we call it nitric acid. Normally is community using this kind of the chemical for stainless steel. How we establish this is basically you can refer to what we call it, ASME G190. So the first one you can look at here. For stainless steel, they mention about the nitric acid, but with a different concentration, and they also mention in terms of the condition of the temperature itself. However, the one that they recommend in terms of the concentration, we didn't follow straight away. We do some readjustment based on our condition of the piping and equipment itself. We don't need necessary to be so acidic. We don't need to be so what we call it, higher pH. So that kind of arrangement we adjust internally. So at the end of the day, I think we end up with the 5% concentration of the nitric acid. So I think nitric acid is more on the straightforward because you can refer to reference the international reference such as ESTM G190. But for carbon steel, you have to do some very detailed comparison because at the end of the day, it's up to you how you want to achieve what kind of the criteria that you want to achieve. All right, that one we already touched on the overview of 3D. We already touched on the chemical. We already touched on the chemical for stainless steel. Then we touch on the how do we execute the job itself. I think I already mentioned earlier on the high level on the circulation itself, but we go with the step by step. Step by step, that's mean from zero time zero, and from time zero is here, starting here, from time here zero, and then from time 100, which is completely complete for chemical cleaning. Okay, for chemical cleaning, I think as I told you earlier, we required to establish the circulation itself. We start with the pump. So we start with the configuration centrifugal pump. So we will start with the pump. So if we look at here, the pump itself, we have the fixed piping, and then we also do have the flow transmitter because during the engineering we have to ensure every single loop we do have the dedicated flow required. So because we have to ensure the velocity itself, the one that we establish, able to remove the chloride corrosion in the piping itself. So the establishment of the fluoride, we will monitor this flow meter. Then we also do have the flexible hose. Of course, the piping itself we cannot drop down, we cannot bring it to the ground, because then we have to stick where they are in the original location. So we have to bring or choose the method how can we bring the chemical upstairs. Upstairs, that's mean the location of the piping itself lah. So we have to connect with the flexible hose, and then you have the connection of the what we call it, the ball valve. Then last not least is the piping itself, and then the return with the filter. Return with the filter to remove all the debris or the chloride corrosion in this filter. But be in mind, in this filter we do have the pressure differential monitoring, so we can see whenever you have the high DP across this filter, then you can start that your system already saturated, and then you have to do the changes of your filter. Last not least is about tank. Okay, the tank itself is where is the dimming water and the chemical itself lah. You locate all the chemical and dimming water here. What is it? This one, just want to a little bit explain to you. This one is, we call it the IBC tank lah. So this one is the from the external, where we transport all the chemical and dimming water. We put the external, and we have the temporary pump. This one we call it different pump. So we transfer the external, the external dimming water and chemical itself into the permanent chemical tank, and after that we can transfer to the pump and to establish the circulation. That's in terms of the mechanism how the circulation works. I go with the step number one. Step number one in the criteria. Step number one, we have to establish the circulation of the dimming water. The MW is dimming water. This is the, we call it the short form itself. Okay, first we need to establish the free flushing. Why we need to establish the free flushing? First, we want to use only dimming water to remove all the chloride corrosion by dimming water itself. Something that the chloride corrosion who are having the, what you call it, the smoke, what we call the soft contact with the pipe. So the one that we can remove easily using the flush water. Okay, this one, as I told you, this one is more on the high level of first introduction of the high velocity. In terms of the acceptance criteria, of course, during the pre-flushing, we anticipating that to have the very plateau of the chloride reading, because your chloride is not going to be increased. They will end up with the plateau reading because there is no more additional chloride source. So in the first free flushing, we will anticipate the chloride reading should be plateau for after 2 times. If doesn't plateau at all, we just allow 5 hours. Why 5 hours? Basically, during the lab testing, we anticipate and we are having experience after 9 hours, you won't end up, or you won't have the chloride increasing anymore. It's normally after 9 hours, they will start to have the plateau number for chloride. That one is for free flushing. After free flushing using the water, everything is all the, what we call it, the easy or soft engagement between chloride and pipe already removed. Then we introduce our chemical, regardless carbon steel chemical or nitric acid for stainless steel chemical. So during this time, we'll entirely remove the chloride, which is our limit is basically we also need to have the plateau chloride reading, but this one entirely remove, and then the chloride reading here and here is even higher because you remove all the hard chloride and hard the one who end up with a long time during in the piping itself. Everything will be removed, and then normally we do it in the 2 times of the circulation. 2 times is about, 1 time is about 3 hours, so 2 times is about 6 hours. But if more than 2 times doesn't work, we only allow 10 hours. Why 10 hours? It's just back to the corrosion allowance. How long we should we open for contact with the chemical itself. We cannot have the longer time because of we also need to protect our thickness. So that's the reason we just limit for 10 hours. Last not least, after your chemical itself clear, then you have to drain, and then you flush it back because of you have to ensure all the chemical residue are removed. There is no more chemical inside your equipment or your piping itself. So how we do establish that? Using the another dimming water, and then last not least, for dimming water itself, we have to ensure the dimming water quality, the one that we establish here, is same as the typical dimming water, the one that we introduced, which is around 6 to 8 pH rating. Okay, that's a detail on the execution method. All right, this one is more on the step by step. I think previous slide, as I shared to you earlier, the previous slide is the one that I, what you call it, the one that I having the explanation. Okay, the first one is more on the one that I explained earlier lah. If you cannot achieve the certain plateau, you have to revert back to the original method. What I just want to highlight here is for the last one. The last one is more on the safety and environment. After all in all, after we complete everything, all the waste, we put it in the one location and we send it to quality alam, because at the end of the day, we also have to take care of our environmental impact as well. Okay, we go to next slide. All right. Okay, I think after explanation of the method on the result, on the method itself, let's we go to the result. Okay, this table you need to understand. This table is more on the step during the execution itself. So if you look at here, every single step we do have checklist. Every single step. See, first, if we look at here, we do also have the flushing. We do have also chemical cleaning. We do also have the post flushing, and after that, we do also have the nitrogen dry out, because we have to ensure we have to remove every single thing and revert back to the original condition of the piping and equipment itself. But I want to share here, every single thing we have to tick here, because of we have to ensure what comment sheet itself is every single thing we anticipate and we check every single statement. So every single loop 11, 12, and loop 14 and number 1 itself, we cover everything. So that's the message from this result. Okay, we go more a little bit technical. If you look at here, just how to read. If you look at here, every single loop, how we establish is how we declare that every single loop already clean and already restored the condition is in terms of the pH and chloride. If you look at here, the purple one, every single chloride is less than 50 ppm. That's our message here lah. And then, so every single thing we have to ensure that there is no more chloride left over in our piping. There's a message here. And then after the chemical cleaning, as I told you here, we have to remove all the chemical and all the water the leftover inside the pipe. How we do that is basically we do the nitrogen dry out. How we ensure nitrogen dry out achieve our target, achieve our intention by monitoring their dew point. What kind of dew point that we have to monitor? We have to ensure every dew point we are managed to achieve minus 65 degree or below even better. Why minus 65? Because of moisture concentration. Because in our system, we required certain number of the allowable moisture content. So that concentration of the moisture content we translate to temperature, which is we require equivalent to minimum minus 65. That's how you should read this graph. And basically the blue one is more on the time taken. Maybe a little bit, if anyone later ask why time taken certain loop having the longer time, maybe we can discuss a little bit later during the question. But my intention here, every single loop they have their own time taken to achieve minus 65. But all in all of them we are able to manage to achieve within the time frame. Okay, we go to observation, what we found. I think for this slide we don't need to understand on the very lengthy sentence. What we just want to highlight here, I just want to highlight here, we segregate and we divide every single finding for each category, which is we categorize by worst, moderate, and minor. I think just focus on the worst lah, the one that is I think is more related and more on the impact, the having the high impact is more on the worst. Okay. The numbering itself is why we say worst. Numbering the yellow one, sorry, the orange one is loop 2, 3, 9, 11, 6, 13, and 14. How you should read these boxes. Okay, we go to worst. I think the worst one is loop 11, and I think another one is loop 9. If you look at here, the loop 1 is 11 is so badly corroded, and then after the cleaning itself, if you look at the impact looks revert to original condition, which is all the corrosion we are managed to having to have the complete removal of the corrosion. And then if you look at number 9, as I told you, number 9, see this one is very bad, and then this is the after our chemical cleaning, so revert to the original plan. How can we manage to get this picture is, I think during that time we have the boroscope camera, so we can assess, I think we can assess, I think up to 10 meter from the point of the first point of the cable of the boroscope itself. So that's the reason we can assess up to very deep location of the pipe itself. I think this one is more moderate. I don't want to go through on the moderate. I just want to focus on the worst one. Okay. Apart from that, apart from the piping, we also do some cleaning on the control valve. And then this one I told you is more on the focus the loop 11. All right. In the conclusion, the one that I think I would like to conclude and share with everybody, and the one that the key message here is, as long as you are having the good collaboration or you are having the good teamwork, you can anticipate there is a light in the end of your tunnel. So that's why I think the key message here. And then the last thing is about the chemical cleaning itself. We can consider this solution as part of the part of the alternative way, rather than using the conventional restoration method to restore the integrity of the plant. I think that's all from myself. I think after this we can having the detailed discussion and in the detailed question and answer session. Thank you very much. That's all from my side.
Okay. Thank you, Saifuddin, for the very interesting sharing with us this morning. I see that there are some questions in the question box. The first one I answered on behalf, but I hope it's correct. One of our audience members asked what LTSU means. So I replied that it means low temperature separation unit. Is that correct?
Yes, 100% correct.
Okay, thank you. So based on my earlier memory, I guess. So anyway, so I'll just run through. I have here some questions coming from the audience in the question box. Let me maybe run through, let's say, one of them. So this one coming from Cik Muhammad Nizam, Cik Aziz. So his question is, this one, I guess, when you were talking in one of your earlier slides. So does the chloride content remarks on the portion of piping system extracted from the HMB or based on simulation after the findings of corrosion?
Okay.
I guess this one at the earlier slide.
All right, in the earlier slide. Okay.
Yeah, whether the chloride content remark is based on your HMB or it's based on simulation.
Right. No.
Yeah, I think that's the one.
Okay. First of all, in the HMB there is no chloride at all. Right? There is no chloride at all. And then based on our simulation, yes, that one, because of, as I told you earlier, there is a dedicated team that look after on the root cause. Of course, I think I one of them, but I think the source of the chloride itself is from the, I think is from the we call it the upstream of the system itself. But how we prove the chloride impact is via the simulation, because of course we do have the some sampling and checking in term of the what we call it, the concentration and the component of the sampling point itself. How we verify it is by simulation, because having the simulation, we can play around with the what kind of temperature that kind of the substance exposed, and what kind of pressure that substance exposed, and last not least, at what concentration that you will start to having the liquid, we call it the HCl itself lah, the hydrochloric acid itself. Because without HCl, it won't impact your condition, you won't impact your piping. Is chloride in the vapor form, nothing harm. Yeah. And should am I hope I can able to meet your expectation to answer, but you can further question on that particular question. Very interesting question. Thank you. Yeah.
Okay, all right. Thank you, Cik Saifuddin. I hope that answers the question from Cik Nizam, Muhammad Nizam. So he also has another question. Cik Muhammad Nizam, Cik Aziz here. Okay, his question is, some of the valves and spools are removed during the process. So do these items also undergo local chemical cleaning outside of the loops?
Yes, exactly correct. Because all the valve, manual valve and control valve, we take it and we send to workshop, and we do it, the chemical cleaning itself in the workshop. It's not internal inside the plant, because we can do it that one separately because of easy to transportation. You are right, 100% right.
Okay, so maybe I just want to follow up, since these are all removed to the, let's say, workshop outside. So what's the process like? Is it like you dump everything in a like a pit?
No, it's basically we can do it manually, because you can use, normally we just using the spray. Let's say we are using salicylate. You just fill up your spray, portable spray, and then you just spray the valve itself, and after a while you spray again with the dimming water, and then you spray again, and then you use the pH pepper and check whether the surface itself is the surface itself is neutralized or not. Because as long as your surface of the valve itself is 6 to 8, that means your condition is back to normal one. If your pH reading is less than 6, then you still have some chemical traces, so you have to remove by using the spray of dimming water lah.
Okay. Thank you for that. So okay, let me just go to the other question. There's also another question coming from Cik Muhammad Nizam, but let me just jump to another audience member first. Mr. Chui Jia Hong asking, what is ICON? ICON.
I think that one is we call it PETRONAS in-house simulation name. Just a name. That one just a name. I think normally last time the name of the simulator itself. I think commonly industry we are using HYSYS, right? HYSYS. So
yes.
This one is more on the the one that PETRONAS developed by our own. So we are using our own simulator.
So this basically simulation apps mainly, right?
Yes,
besides using HYSYS in PETRONAS, you are using ICON, the name of the application. Okay, thank you.
Yeah.
So this one is a common question we normally get during our technical talk by the speakers. So this one, Encik Hong An is asking whether you can share the presentation slide with the audience. So I mean, earlier on I was told somehow, I mean, you are you are not supposed, you cannot mainly share, but maybe you can answer that.
Okay, first of all, thank you for that question. I think thank you, and thank you for your interest to having to have that technical presentation. But I think unfortunately, because of this one is more on the preparatory, and as well as the something that we are not allowed to share to outside. However, I can offer you can contact me directly if you are interested to more detail and how exactly from zero to finish, how we execute itself. I'm more than happy to share this one personally. But however, in terms of the conceptually, I'm not in the position to share this slide lah. Yeah.
Okay, all
I
right.
think
Okay, understand. I mean, we sometimes some of the speakers also, because of the company policy, they are not able to share the presentation slide. No problem. I mean, since you mentioned that, if let's say any of the audience members want to contact you, how do they go about?
I think I can share my personal email and my
Yeah.
personal phone number. You can contact
Okay.
myself directly lah. I'm more than happy
Okay.
to
All
share
right.
the
Maybe for the audience, if let's say you want to get in touch with our speaker, Cik Saifuddin, maybe you could communicate with the secretariat, IEM secretariat. Then we'll see how we can get in touch with Cik Saifuddin in case you have more questions or more clarification from him later. Okay, thank you. Then let me just go back to Cik Muhammad Nizam just now. He also has another question. Okay, this one in general, how can you relate the worst condition you mentioned in the slide? I guess this one, maybe a typo here. Let me.
yeah, the worst condition and moderate and order stream, right? Okay.
Can you relate the worst condition you mentioned with the chloride? How can content at the respective content will be more affected? Okay, I guess if let's say I can rephrase. Does the chloride content relate to the corrosion condition? I mean, higher chloride content, worse corrosion condition. I guess that's the question here. Or either no, because of higher, lower corrosion.
Okay. I think thanks Encik Rafidi. I think this one will revert back. There's more on related to this slide again. But please let me know if you can see or not this slide.
Yes, we can see.
All right. Agree with you. The findings that I show you, I think the end slide is more on the picture during the execution. The finding itself is judged with our initial anticipation, because if you look at here, before during that particular execution, we do have the leakage in this line, and then this is the line that we found the most of the condition is worse. If you look at here, the one that I show in the blue font is having the high concentration of the chloride. So same goes to here, and here, and here. So this is the area that we are having the observation of the worst condition. I totally agree. if you are anticipating the higher chloride concentration, you are anticipating the higher concentration of the pH. Sorry, we call it the lower pH reading, and then by then you will start experiencing the worst condition of the piping itself. That's what I can conclude lah. What we anticipate, yes, we found it's not exactly, but what we anticipate is same as what we found during the real execution. Hope answer your question.
Yeah, okay, thank you. I hope, that answers the question from Cik Muhammad Nizam. Okay, keep on the questions coming. We still have some more time left. You can type question chat, question box, and I'll read it for the speaker to answer. Okay, there's one new question coming in from Mr. Choi Jia Hong again. What is high DP?
High DP is the high differential pressure.
Differential pressure.
High differential pressure.
Right. Maybe you want to explain further.
Yeah. Basically, you just imagine high DP is, let's say the start point is P1 and the end point is P2. So P2 minus P1 is become higher. That's the high differential pressure, because normally for every single differential pressure we have our standard or our normal number. Let's say the normal number is 0.5 bar. So somehow is exceeding the normal number. Exceeding, that means could be they can went up to 3 bar. So something is happened, something is wrong happened. So that's kind of the situation, or that kind of the situation that triggering us and keep alarming us. So that's our message there lah. So from the DP itself, we can start to give the signal or give the indication to us something wrong is happened. Okay.
All right, thank you Cik Saifuddin. Okay, we still have time left. If there's any member of the audience wants to ask any question for Cik Saifuddin, maybe I'll give we'll give some few more minutes. Okay, I don't see any more questions coming in. So as I mentioned earlier also, if let's say you have any more clarification required, maybe you could communicate with our secretariat, Ms. Surayani. So she'll provide the contact number or contact email of Cik Saifuddin to you in case you want to learn more from Cik Saifuddin on his experience in doing this sort of chemical cleaning. Okay. If there's nothing more from the audience, I also would like to take this opportunity to thank Cik Saifuddin for joining us this morning from Seoul, for taking the time to share this interesting topic, chemical cleaning, how it restores the integrity in the oil and gas plant equipment. Thank you so much again, Cik Saifuddin. We look forward to your participation in the future. To all of us, let's again give a round of virtual applause to Cik Saifuddin for coming and joining us this morning. Thank you so much. I hope everybody will have a good day ahead. Thank you, and please continue to join activities organized by Oil, Gas and Mining Technical Division as well as Chemical Engineering Technical Division, and we look forward to see you again in the future. Thank you so much.
Yeah, thank you very much. Thank you. See you next time. Thank you, Encik Rafidi.
Yeah.
Thank you, sir.
Thank you, Cik Saifuddin. Thank you to all as well.
Thank you.